Sails originally were square riggers. Over time, other shapes were used to try to combat the issue that square sails only worked when the wind was behind the boat pushing it forward. By changing to the classic triangular sail, the multiple points of sail concept was finally able to be taken advantage of. As time went on, new designs were created to improve a boat's ability to sail more into the wind. Rigid airfoils, also known as wing boats, were invented, which helped increase the points of sail as well.
A yacht sail creates a pressure difference between the front of the sail and behind the sail through the use of an airfoil. This force from the sail is equal to the pressure difference times the area it is applied to. Typically, in sailing, you can sail 30 degrees to either side of the wind when going upwind. You cannot go directly 0 degrees into the wind, though, because it will make the sail flap, not allowing an airfoil to form. When going downwind, the sails are usually parallel to the boat, and the force is produced by the wind filling the sails with air. The keel, an underwater stabilizer, ensures that the net force on the boat are in the forward direction. This makes sure the boat does not flip as well. Airfoils allow the sailor to go almost directly into the wind, while flexible sails make it only possible to sail downwind.
So there are basically two types of sails that are used today in modern sailing. And these sails consist of the traditional cloth sail. This type of sail is generally more flexible and made up of a softer material. And the second type of sail is the rigid wing sail with airfoils. So this type of sail is much harder and does not flex in the wind. So our group came up with the hypothesis based on the effectiveness of these sails, and it is the rigid sail with airfoils will be more effective in propelling the boat as opposed to the flexible cloth sail due to the lift created by the airfoils on the rigid sail.
To calculate the airfoil forces is my part of the job. And first of all, I calculated the lift force by using the equation of rho GV. Rho stands for density, V stands for volume. And I picked the boat size is called Hobby Bravo. And the sail area for that boat is 86 feet square and 4 feet deep with under the water. And the seawater density is about 1,020 kilograms per meter cube. And this actually produced the lifting force of the boat was roughly about 97,000 newtons. And this gives the specific number. And the total weight of the boat is roughly about 3,300 newtons. And we can see the lifting force is way bigger than the boat's weight itself. So the boat could stay on the surface of the water without any external forces. In the second part, I did the drag force, and that will actually produce the force to move the boat, to motivate the boat on the ocean by using the equation drag force equals to 0.5 times fluid density times square of velocity of the boat and times the sail area. And if we assume the boat sail from the Oregon port outward, the wind speed of that port would be 19 miles per hour, roughly. And the fluid density is the same, kind of like 1,020 kilograms per meter cube. And the sailing area, as we said before, is 86 feet square. And this will provide the drag force roughly about 1.68 times 10 to the 7th newtons. And if we use this force divided by the boat's weight, we can get an acceleration speed about roughly 5.4 meters per square seconds. And without consider all the resistance of air, resistance of seawater, and the different wind speed and the correct angle of the airfoil, this will be the acceleration of the boat that can get under 19 miles per hour for wind speed. But if we consider all the resistance and the realistic considerations, the acceleration would be smaller by a scale.
The first sails were square-shaped. Over time, new shapes of sails were used to try to fix the issue where if wind was not blowing behind the sails, the yachts wouldn't move. Eventually, multiple points of sail were used to fix the initial problem yachts had. The pressure difference between the front and back of a yacht sail is created through the use of an airfoil. If we were sailing upwind, we can sail 30 degrees to either side of the wind. One thing we need to take into consideration is sailing at 0 degrees, and it makes the sail flap, which consequently prevents the airfoil from forming. We use the keel to ensure the net forces on the boat are in the moving forward direction. Finally, rigid sails are more effective in propelling the boat than cloth sails because of the lift that's created by the airfoils on the rigid sail.